Good morning, students. Let us continue the chapter Thermodynamics. So far, in this chapter, we have seen, starting with definition of thermodynamics, the zeroth law of thermodynamics, the first law of thermodynamics, the heat, the temperature, the internal energy, then the relation between heat and internal energy, and also we have seen some terms like thermodynamic process. What is thermodynamic process? Thermodynamic process is a process in which thermodynamic state of a system is changed. In thermodynamic process, the thermodynamic state of system is changed. In thermodynamic process, the thermodynamic state of a system is changed. Means what is change? There is change in thermodynamic state of a system. So if we wish to understand the thermodynamic process, we must know what is thermodynamic state of a system. We have also seen the thermodynamic state of a system. In short, thermodynamic state of a system is a set of measurable properties. And which are the measurable properties? Like pressure, volume, temperature. These are the measurable properties. And the set of these measurable properties is nothing but the thermodynamic state of a system. This pressure, volume, temperature, these are the measurable properties. We have also seen the definition of these measurable properties. Measurable properties means the properties of system. What is property of system? The property of system is defined as any observable or measurable variable that can be used to characterize the system when that system remain in equilibrium. These properties of system, they are used to characterize the system, and when that system is in equilibrium, that system must be in equilibrium. Now let us see what is thermodynamic equilibrium. Thermodynamic equilibrium. A system is said to be in thermodynamic if it is simultaneously in mechanical equilibrium, chemical equilibrium, and in thermal equilibrium. When that system is simultaneously in mechanical equilibrium, chemical equilibrium, and thermal equilibrium, then we can say that that system is in thermodynamic equilibrium. Now let us see one by one this mechanical equilibrium, chemical equilibrium, and thermal equilibrium. First, let us see what is this mechanical equilibrium. A system is said to be in mechanical equilibrium if there are no unbalanced forces within the system and between the system and its surrounding. Then that system is said to be in mechanical equilibrium. So what is mechanical equilibrium? In mechanical equilibrium, there are no unbalanced forces. In mechanical equilibrium, there are no unbalanced forces within the system. and between system and its surrounding. If there are no unbalanced forces within the system and between the system and its surrounding, then the pressure is uniform. The pressure is uniform. So this is the criteria of this mechanical equilibrium. When the pressure is uniform in all regions of the system, then we say that that system is in mechanical equilibrium. Then the second equilibrium is the chemical equilibrium. Let us see what is this chemical equilibrium. A system is said to be in chemical equilibrium when there are no chemical reactions. When there are no chemical reactions. The chemical reactions are not there. When there are no chemical reactions going on within the system. In that system, there is absence of any chemical reaction. No chemical reaction is going on within the system. And the second criteria is, or there is no transfer of matter from one part of system to other part of system. Due to diffusion. A system is said to be in chemical equilibrium if there are no chemical reactions. The chemical reactions are absent within that system, then we say that that system is in chemical equilibrium. And the second criteria is no matter is transferred from one part of system to another part of system. The system is in chemical equilibrium when the chemical composition is uniform. The chemical composition of that system is uniform. Then we say that that system is in chemical equilibrium. And the third equilibrium, that is the thermal equilibrium. A system is said to be in thermal equilibrium when the temperature of system is uniform. The temperature of system is uniform. This is the criteria for what? The thermal equilibrium. So for this thermal equilibrium, the temperature must be uniform. So these are the three equilibrium. The first one is mechanical equilibrium, the second one is chemical equilibrium, and the third one is thermal equilibrium. When the pressure is uniform, when the chemical composition is uniform, when the temperature is uniform, then we say that that system is in thermodynamic equilibrium. I hope you understood this thermodynamic equilibrium. Now let us see the next, that is the thermodynamic state variable. Thermodynamic state variable and equation of state. What is this thermodynamic state variable? Thermodynamic state variable, they are the property of system. The property of system, that is also known as state variable, that is also known as system variable. The important feature is they are independent of the path. If these variables, they are depend on the path, then they are not the state variable, but they are the path variable. The state variable, they are independent of the path, they are not depend on the path. Now let us consider a simple example. Suppose we are having a ball, and suppose this ball is get punctured. From here this ball is get punctured. Then what we observe? We observe that the ear inside this ball suddenly expand and it transfer to the atmosphere. When this air is suddenly expand and get transferred to atmosphere, then the pressure is not uniform. And when the pressure, that is the state variable, that is not uniform, then that system is not in equilibrium. The system is in inequilibrium. And when that system is not in equilibrium, then we cannot define the thermodynamic processes. Or in simple word, we may say that the thermodynamic state variable, they describe the equilibrium state of a system. This thermodynamic state variable, they are constant, and as they are constant, they define the equilibrium state of a system. And now let us see the equation of state. Equation of state means what? That is a mathematical relation between the state variables. What is this equation of state? That is the mathematical relation. That is just a mathematical relation between the state variables. And one of the equation which is ideal gas equation is PV is equal to nRT. In this equation, P is pressure, it is state variable. V is volume, it is state variable. This temperature is state variable, and these N and R, these are constant. As these two, they are constant, if we know the values of P and V, then we get the value of T. So only two independent variables are known to us, then we can find the third variable. It is not necessary that all the variables, they are the independent variable. Only two of these three variables are independent variable, then we can find the third variable. Suppose we know the volume and temperature, then we can find the pressure. This is all about the thermodynamic equilibrium, thermodynamic state variable, and equation of state. Thank you.